We're going to be looking at a quadrilateral, more specifically a parallelogram. So since you're allowed to use notes on tests and quizzes this year, it would be very smart to write down these characteristics, or once I'm done telling you all the characteristics, to take a picture of this screen. So there are 5 characteristics of a parallelogram that make it a parallelogram. So the first characteristic of a parallelogram are that both sets of opposite sides are parallel to one another. So in our diagram, our top and its opposite bottom is parallel. That's why it's marked with 2 arrows. Okay, and then the left and right sides are parallel. I have to use 2 arrows for the second set to show that it's a different set of parallel lines than my first. The next characteristic is that both sets of opposite sides are congruent. So that means my top and bottom lines are congruent. The left and right lines are also congruent. Once again, 1 hash mark for top, 2 for the sides. Third, we have opposite sets, or both sets of opposite angles are congruent. So that means the angles that are diagonal from one another. So the bottom left angle is congruent to the top right, and the bottom right angle is congruent to the top left. So both sets of opposite angles are congruent to each other. Consecutive angles are supplementary. So that means if I know the degree of one of these angles, I can actually find the degrees of all. So if this bottom angle is 60 degrees, obviously the one across from it would also be 60, but the angles that are consecutive to it are supplementary. So that means the angles to both sides of it need to add up to 180 degrees. So 60 plus 120 is 180. So that means, is 120. So that means this angle is 120. Since it's supplementary to the angle beside it, that's going to make this 60, and it's supplementary again, so that's going to be 120. Notice that opposite angles are congruent to each other as well. And then our last characteristic is that the diagonals bisect one another. So I'm going to draw on here a diagonal. We talked about a diagonal in the last section. Okay, so our diagonal goes from opposite angle to opposite angle. So we have 2 diagonals, and they bisect one another, meaning that this coordinate in the middle acts as a midpoint. And then we can make our little tick marks. So this portion, we can call it AM, is going to be congruent to MC. BM is congruent to MD. So the diagonals bisect one another. This would be an excellent time to take a picture for notes. So we're going to use that information to solve. So we want to find the value of x. If I look, x and 12 do not have degrees by it, so that means they are representative of sides. We know in a parallelogram that opposite sides are congruent. Therefore, x plus 4 is equal to its opposite side of 12. I solve by subtracting each side by 4, and x's value is 8. When I'm trying to find y does have a degree, so that means we're looking at the angle. We know that in a parallelogram, opposite angles are congruent. So y's degrees, its opposite is this entire angle of 65. So y's value is 65. Next, we're trying to find the value of BC. That is a side, so we go from B to C. Opposite sides of parallelograms are congruent, so its opposite side is AD, which is 10. Find the measure of angle ADC. So we go from A to D to C. So we're looking at this angle right here. Well, they don't give us any information with the opposite angle. So we need to use the fact that its consecutive angle is supplementary. So I can either set up an equation. We can say x plus 65 is equal to 180, or you can just say, I know these two need to equal 180, so 180 minus 65 will give me an answer of 115 degrees. And then they want us to find the value of MB. So MB is a diagonal. Now remember, diagonals cross each other, and they intersect each other, and they bisect one another. So M serves as a midpoint. So since D to M is 5.1, that means M to B is also 5.1. So we have 4 coordinates, and we want to find the intersection of the diagonals. So I'm just going to plot the coordinates 1, 4 for L, 7, 4 for M, 6, 0 is N, and 0, 0 is O. And I'm going to connect those coordinates. Now they want us to know where the diagonals intersect. So if I drew this perfectly, I could see what the intersection is. So I go from opposite angle to opposite angle, opposite angle to opposite angle. So it does look like it intersects somewhere in between. So since I know diagonals bisect one another, that means that this coordinate in the middle, we'll call it C, acts as a midpoint. So I either need to find the midpoint of LN, or I could find the midpoint of segment MO. It doesn't make a difference because it's in the middle of either of them. So I'm going to choose MO just because O has 0, and that's easy to add. So our midpoint is where we add the x's together, divide by 2, add the y's together, divide by 2. So my x values are 7 and 0. My y values are 4 and 0. 7 plus 0 is 7, divided by 2 is 3.5. 4 plus 0 is 4, divided by 2 is 2. So it does appear that my intersection is about at 3.5 and 2. I'm given 3 vertices. W is at -1, -3. X is at -3, +2. And Z is at +4, -4. And I want to know where my last coordinate of Y would be. So we know that opposite sides of a parallelogram are congruent. So I'm going to be working with the slope. So if I look at my graph, from W up to X, I go up 1, 2, 3, 4, 5 spaces and back 2. So I'm going to mimic that with Z. I'm going to go up 1, 2, 3, 4, 5 spaces and back 2. Giving them the same slope means that my 2 lines are going to be parallel to each other, which is important because opposite sides are parallel. So both of these lines that I've just created are parallel to one another since they have the same exact slope. I can check the slope of my other 2 lines. So from W to Z, I go down 1 over 1, 2, 3, 4, 5. From X to Y, I go down 1 over 1, 2, 3, 4, 5. So once again, same slope, which means these two sides are also parallel. So my coordinate of y is 2, 1. So then the last part about parallelograms is that the converse of a parallelogram is also true. So if we say any of these 5 characteristics that I'm about to name, then we can draw the conclusion that it's not just a quadrilateral, it's a parallelogram. So if we find both sets of opposite angles are parallel, then we can conclude it's a parallelogram. If both sets of opposite sides are congruent, we can conclude it's a parallelogram. If both sets of opposite angles are congruent, then we can conclude it's a parallelogram. These match exactly from our first set. Now 4 is a tad bit different. This converse says you only have to have one set of opposite sides that are both parallel and congruent, and then you can draw the conclusion that it's parallel. And 5 is very similar to parallel characteristics. If the diagonals bisect each other, then we can conclude that it's parallel. So I have 2 quadrilaterals here. We have, it looks like we're at an amusement park, and this is a door in England. And we want to see, are these quadrilaterals actually parallelograms? So looking at this first example of the amusement park, I see that opposite sides are 38, and the other set of opposite sides are 16. So that meets our first requirement. So yes, this is a parallelogram. My reasoning is that both sets of opposite sides are, not parallel, they are congruent. So it's the second reasoning. Looking at our door, I have opposite sides that are both parallel and congruent. So this reaches standard number 4. So I can say, yes, this is a parallelogram. The reason is one set of opposite sides is parallel and congruent. So we're just going to go through a couple of examples to make sure you got it. So I want you to find the values of x and y that make this a quadrilateral. So we have to know, if we look at x and y, those are opposite angles. And what do we know about opposite angles in order to be a parallelogram? Well, opposite angles have to be congruent. So if they need to be congruent, that means that they are equal. So I'm going to set angle A equal to angle C, and angle B equal to angle D, and solve. State the theorem. So this is from the last slide, and once again, this is a good slide to take a picture of for your notes. Which one of those theorems show that these quadrilaterals are actually a parallelogram? So what is your reasoning that 3 is a parallelogram? What's your reasoning that 4 is? And what's your reasoning that 5 is? And then lastly, for what value of x is this quadrilateral a parallelogram? We are dealing with the diagonals. We know that diagonals bisect one another. So once again, opposite sides of the diagonal are congruent. So we're going to set these equal to each other and solve.